All right, hello One Act folks. We are still in section 5.1 doing the last couple of examples, but before we do this part 2, these last 2 examples, I want to do another one of these where you're finding the mean, variance, standard deviation, because lots of people were very terribly confused yesterday, yeah? Is that valid? Like making this table, finding mean, variance, standard deviation, you're like, I don't care. Okay, so you have lots of room at the very, very, very bottom right here. I'm going to put a table right here. This gives us enough room to do this problem, whatever. We don't need that much room, okay? So down here at the very, very, very bottom of your notes before the homework, right, we're going to do a table, and we're going to flip 3 coins, okay? And we're going to put it in terms of tails now. In terms of tails, just because we picked on heads a whole lot. We're going to do it in terms of tails. Quit it. Write this down. In terms of tails, we're going to make a probability distribution, okay, where we have x over here, right? Then we've got like p of x over here, and that's what our probability table looks like, right? Okay. All right, and we're flipping 3 coins. Okay, how many outcomes do I have if I flip 3 coins, by the way? Who said it? 8, right? 3 coins, 1, 2, 3, heads or tails, heads or tails, heads or tails, 2 times 2 times 2 is 8, yeah? Okay, I could get A, heads, heads, heads. What else? Tails, tails, tails. Okay, there's 8 of them. All right, let's list them all. Heads, heads, tails, heads, tails, heads, heads, tails, tails. Okay, those are all the ones that start with heads. Then I've got tails, tails, heads, tails, heads, tails, and tails, heads, heads. There we go. Those are all 8 of them. Okay? All right. Now, if I'm doing everything in terms of tails, X is the number of tails that I get, right? Okay? So what could I have happen if I have 3 coins? I could get 0 tails. I could get 1 tail. I could get 2 tails. I could get 3 tails, right? Okay? All right. We want to know the probability that I get 0 tails. The probability that I get 0 tails is just that one, which is 1/8, which is 0.125. Awesome. 1 tail would be this one, or this one, or this one. Yeah? 3/8. And 3/8 is 0.375. Okay? 2 tails is like this one. No, I did that wrong. No, whatever. 3/8 and then 1/8, whatever. I circled the wrong ones up there. Sorry. 0.375, we know this table, right? And then 1/8 is the chances of getting all 3 tails, which is 0.125. This is the probability table for 3 tails, or for 3 coins, right? Okay, all right, now, if I want to find the average number of tails I should get if I flip 3 coins, what's the average number of tails I should get? 1 or 2. They're going to put it as a decimal as 1.5, right? Like 1.5 times, if I flip the coin 3 times, 1.5 times it should show up tails. I understand that you can't get 1.5 times, but that's just how that works, okay? They're going to say that the average is 1.5. Got it. Okay. But how do you calculate that, right? What we do is we take the sum of all the x times the p of x. That means this column times this column. And then I add them all together, right? That's what we do. We're finding the average number. So if I take 0 times 0.125, I get 0. If I take 1 times 0.375, I get 0.375. If I take 2 times 0.375, it is like 0.75. I don't know if that's right. Is that right? Okay. If I take 3 times 0.125, that is 0.375. Okay. And if I add those all up, what do I get? What? If I add all these up, you get 1.5, just like we said, right? What's the average number of tails I should get if I flip 3 coins? 1.5, which you can't get 1.5, but that's the thing. What should all of these guys add up to be, by the way? 1. If it doesn't, then this is not a probability table and it's not legit. Okay, we can't even do this thing. All right, now, that is the mean. We just found the mean, okay? That's how you find the average. They label that as mu. Mu is 1.5. Mu is the average number. And we do that by taking x times p of x and adding them all together. Now, we want to find the variance. The variance they call sigma squared, okay? And the variance is the sum of all the, they do it like this, x minus mu squared times p of x. That's a lot of junk to go on there, okay? All right, so I got to do this over and over and over again, okay? I really have just this inside part to do. X minus mu times p of x, okay? In my first row, what is x? 0 minus, what's mu? 1.5 squared times, what's p of x? 0.125. Do you see where these numbers are coming from? X minus mu times p, or squared, times p of x, right? Second row. 1 is my x, right? Minus 1.5 squared times, what's p of x? 0.375. Next row. 2 minus 1.5 squared times p of x, 0.375. Do we understand what we're doing here? Yeah? Ish, maybe? Okay, last row. What's he look like? Oh, gosh. Last row. What's x? 3 minus 1.5 squared times p of x, 0.125. Yeah? Okay, now we got to do some math. 0.125 is p of x right here. You're going off of this number. That's not the right number. You got to go p of x. P of x is this column. Yep. Okay, calculator. All right. This is the first row times 0.125. Oh, gosh. 1.5 squared times 0.125. I got 0.28125. We don't necessarily have to go that many decimal places, but we will, sure. 0.5 squared times 0.375. By the way, help yourself out here. 0.09375. I do this part in my head. 1 minus 1.5. You can do that in your head, right? It's negative 0.5. In my calculator, I don't type in negative 0.5. I just type in 0.5 because when you square it, the negative goes away anyway, right? So I just help myself out here. This is going to be another 0.5 squared, right? Help yourself out. 0.5 squared times 0.3. Oh, that's the same thing again. True? Yeah, that would be the same thing again. 0.09375. That was stupid. I don't know why I did that. 3 minus 1.5 is 1.5. 1.5 squared is 2.25 times 0.125. This, why does it keep zeroing it out? 1.5 squared times 0.125. Enter. Okay. Oh, that was dumb again. Why did I do that again? I don't know. 25. Right? That should be the same as the top. That was silly. If I add those all together, times 2. 0.28125. My calculator is being dumb. Times 2. I don't know. This calculator is dumb. Somebody give me a better calculator. Oh, never mind. That calculator is like out of batteries or something, and it keeps, and so is that one. Good Lord. Your battery is low. Okay, we'll see if we get through this. 0.28125 times 2 plus 0.09375 times 2. If I add those all together, 0.75. That is the what? That's the variance. That is sigma squared. That's the variance. Do you see how this works? You're just doing that table thing, right? X minus mu squared times p of x, and you do all the things and you add them all up. Okay, that's the variance. How do I find the standard deviation? Yeah, I just want sigma, which is standard deviation. The square root of 0.75 is 0.866. I should have known that. I think I knew that. 0. That's the standard deviation. Okay, denoted as sigma. Wow. How does that math? How does that math out? I thought when you took the square root of a number, it made it smaller. That's making it bigger.
You felt the need to share the super.
Yeah, if it's a number that's less than 1 and you take the square root of it, did you know that you make it bigger? Right? The square root of 1/4 is 1/2. We just made it bigger, right? If it's a number that's less than 1 and you take the square root, it makes it bigger. Okay, fun fact. There you go. Do you see how that works? That is the strategy. That's what you do on number 3 and number 1. You know what I'm talking about? Number 3 here and number 1 here, right? Okay, so you just need to set up your columns as the mean is x times p of x, and I want the sum, right? Got it? So fill that column in. Then you want standard or variance, and you're doing x minus mu squared times p of x. That's how you do this column. Okay, and then the variance will be the sum. And then the square root is the standard deviation. You see what I'm doing here? Okay, that's how you calculate. It's kind of cumbersome. I'm not going to lie. It's not very much fun. But there is that. Okay, that's what you're doing for each one of those tables. Finding the mean, finding the variance, finding the standard deviation. Very nice. Very nice. I know yours is right for this bottom one, number 3, but I don't know. I can look at number 1. I'll look at it. I'll come do it with you. Okay, good? Yes? Okay, you write that down. Is my Dr. Pepper back? I think it is. Field trip. Field trip. It's
Did you want one?
Yeah. I put the second one in there. We came over on a Saturday to do junior high basketball shirts. And like every single person in my family had to take one out of my fridge, so I had to open up the second pack already. Whatever. Okay, beautiful. Beautiful. All right, since we're adulting and Tate's buying a car, which he can't afford, but that's besides the point.
You sound like you do.
While we're adulting, let's talk about insurance. No, that's down here. Never mind. You're talking about insurance on your homework assignment. Okay, so you can be an adult on your homework assignment. I think you're talking about insurance. I think it is like this one right here. This is life insurance. You're talking life insurance. So you can adult on number 3. There you go. But this has to do with these 2 problems up above here. So here we go. We're betting, but this is the same thing as insurance, right? Like insurance is gambling, kind of, right? Yes, right? What you're doing by purchasing insurance is you are placing the risk of you getting into an accident or the risk of you dying on the insurance company, right? Like they are harboring that burden of the risk of you dying or getting into an accident, right? Because they're going to end up paying out the money. You just pay them a lump sum every month, right? Okay? Now, if you get in one too many accidents, they do heighten that lump sum that you pay every month. What's that called? What's that lump sum that you pay every month called?
Deductible?
Nope. Premium. It's insurance premium. Yes. Okay. Deductible is what you pay after, like, you get into an accident, might have a deductible, whatever. Okay, so, anyway, you pay an insurance premium, but that's kind of how this works in gambling. You're paying a premium to them, and then you are getting money back, hopefully, right? Okay? All right, you have $5 to place on a bet. That's kind of like your premium, your insurance premium, okay? In the Golden Nugget Casino in Las Vegas, you have narrowed your choices down to one of 2 bets, okay? The first thing that you're, one of 2, so this is option number 1. This is option number 2. We're going to see which one gives us the better deal. Okay? All right, A is betting a number 7 in roulette. I have no idea what that means, so we're going to read about it, all right? Or, I guess you could bet on the pass line in the game of craps. I don't know. Anybody played game of craps before? Like my husband knows people that have a craps table, and every time they have a bachelor party, they like play at this table, whatever, and then all the money goes back to the groom, right?
I know it's
Okay, whatever.
confusing.
It is kind of confusing, but whatever. I guess if you know it, then it's fun. Whatever. All right. If you bet $5 on the number 7 in roulette, the probability of losing the $5, circle the word losing, is 37 out of 38, which means you win 1 out of every 38 times. 1 out of every 38 times. Okay, so here's the deal. If you win $175. Okay, so here's what we've got going on here. Ready? We have a probability table with 2 outcomes. Either you are going to lose $5 or you are going to gain $175. That's like your 0 and 1 and 2 and 3. Like those are your outcomes that happen, right? Either you're going to gain 175 or you're going to lose 5. Okay, those are the 2 different outcomes. And the probability of that happening is 37 out of 38 and 1 out of 38, right? Those outcomes, okay? Now, they ask, find your expected value. Okay? Expected value. Write this off to the side. Expected value equals the mean. Expected value is what do you expect to have happen? Or what's the mean amount of money that you will get back, right? What's the average amount of money that you will get back? That's you're calculating the mean. How do we find the mean?
Take them, multiply things.
X times P of X, and you add them all together, right? Okay? So if I take negative 5 times 37 out of 38, it comes to be a negative 4.868421. Rounded to that many decimal places. I don't know why they did that, okay? But if you take 175 and you multiply by 1 over 38, it ends up being 4.60. And if you add those together, because we're finding the sum, right? We add those 2 together, you get a negative 26 cents. So if you play this a bunch of times, it will average out to be that you are losing 26 cents per time. Now, there are going to be times that you are going to win, right? You might win 1 time, right? If you play a bunch of times. But if you average all the times that you play, it will come out to be that you are losing 26 cents every time. Why do they make that a thing? Because they want to make money no matter what, right? Even if you win, they want to make sure you lose more than you win. So that's why they set this up to $175, right? They could set that to $500, right? If they set that to $500 though, are you going to end up losing 26 cents every time? No, you're going to probably gain like $3 every time you play if you average it out, right? That's why they set that amount to be $175, so that no matter what, they will end up averaging out to be on top, because you're going to lose 26 cents every time you play the game. Got it? Okay, versus if we do the craps table. If you bet $5 on the pass line in the game of craps, you could either bet $5 and lose $5, or you win $5, right? Now, you're not winning very much, but look at the probability of you winning. The probability of you losing is 251 out of 495. The probability of you winning is 244 over 495. So you have almost a 50% chance of winning, right? Not quite 50%, but almost 50%, right? Okay? So that's why you're not winning as much, because you have better chances of winning, right? Okay? Good? Now, if I'm trying to find the expected value or the average value, I multiply those together. So if you take negative 5 times this number, you get negative this. If you take positive 5 times this number, you get positive this. And if you add them together, you get this much, which means what?
Lose 7 cents.
You're losing, if you average it out, the number of times you play, maybe you play 150 times. I have no idea. You're standing there forever, right? If you play 150 times, you will end up averaging out to losing 7 cents every time you play. Okay, so if you play 100 times, that means you're losing $7 before the end of the night. Does that make sense?
That's not bad.
That's not terrible. I mean, like, you've had some fun out of it, maybe. I don't know. Or you could have been losing way more than 7. But averaged out, it should end up being somewhere close to $7 or 7 cents that you're losing each time, right? So, let's go back to the original problem. Which one should you choose? Which game should you play?
The second one.
The second one. You should play neither of them, because no matter what, you're going to average out to a negative, right? But which one do you negative less? B, play craps. I mean, if you have to play, you should play the craps game because you're going to end up losing less. Does that even make any sense at all, right? You lose less. Okay, so what?
What if you win a ton?
I mean, you might get lucky. If you win, get out, right? If you win 175 bucks, you get out because if you keep playing, it will end up averaging itself out at the end to be approximately losing 7 cents per time. Whatever. So, the moral of the story is don't keep playing. Whatever. Okay, so when we're talking insurance, right? Let's say we're talking insurance, and let's say we're talking that your premium is 100 bucks a month, right?
Just do the
Just wait. Let's say your premium is 100 bucks a month, right? Okay? So negative $100, right? But if you die, you make $1 million, right? Some people are insured for $1 million.
Some people won't.
Some people more. Some people less. It depends, right? Okay, but what's the chances that you're going to die? Like, what's the probability that you're going to, like, live, let's say? What's the probability that you're going to live?
Well, it depends.
Like, so I'd give it like
Like
9,000.
999, like this, probably over this much, right? Like, that might be the chances that you live. I didn't even know if that maths out to the right number.
Need another zero.
I need another zero in there, right? Like, that's maybe the chances that you live, right? The chances that you die is going to be 1 over that, right? You have a 1 in a million chance of dying tomorrow. You have a 999,000 whatever chance of living, right? So I'm going to take this amount times this amount, put it right here. I'm going to take this amount times this amount, put it right here, and I'm going to add the two together. And it's always going to turn out that that number should be negative because the insurance company should end up making money in the end, right? Does that make sense? Okay, the expected value, that is how much money they're going to make every person, right? They will make 7 cents per person. Every insurance policy that they do. Make sense? Whatever that comes out to be, I don't know.
I don't know how to do it on here.
And those aren't, don't do it for those numbers because those aren't the correct numbers.
Oh, I want to see what it is though.
Well, this is what I wanted to do with my life. You ready?
Oh, no.
Like, if I wasn't a teacher, I would be this person.
Risk
Are you ready?
analysis.
This is kind of. They're called actuaries, right? Okay. So don't do this with these numbers, Tate, and for this reason, okay?
I told Aiden to do that.
This amount right here and this amount are determined by these amounts. So what they do is they like draw your blood and they like make you pee in a cup and they take your height and your weight and all these things, right? If you're buying insurance and they calculate all of those things and they calculate the risk that you will die tomorrow or that you'll get cancer or whatever, right? Like, and they put you into a tiered category. So there's like level 1 risk and then there's level 4 risk, okay? Like I'm like in a healthy risk. My husband's a step below me because
You work
You
some
make money with that.
construction.
well, I don't even think they take that into play. He chews, right? So he has a nicotine addiction, whatever, which could cause him to be predisposed to, I'm just being transparent, he's predisposed to cancer, right? Like he has a higher chance of cancer than I would, right? So his risk of dying is a little bit higher than mine. Therefore,
Yes.
they're going to charge him, if he wants $1 million of health insurance, they're going to charge him way more for this number than I am, right? They're going to charge him maybe $300 a year instead of $100, right? Okay? And that's actually pretty cheap for a $1 million life insurance policy. It's usually way more than that. But anyway, does that make sense? These numbers, depending on these numbers, right? Because these are determined, like these numbers are determined by what category you're in for health-wise. Those numbers, they crunch and they figure out what your premium should be. Because they want to make sure that the expected value, no matter what, is going to put money into their pocket and they're not going to lose out. Have you ever heard of insurance companies going bankrupt?
Yeah.
That happens, okay? And it's because they got an unlucky year where a lot of people died and they had to pay out a lot of policies and they went in the hole. Too much. Okay? So they got to make sure their calculations are correct and they're doing all their job correctly so that they're making money no matter what. Got it?
You should have been an actuary.
I'm
You could be rich right
I know, right. Instead, I'll just slum with you, Tate. right? Okay, that's what you need for number 3. Questions? I'm telling you how to live your life, kid.
Okay, you should stop.
All right, goodbye.